Welcome back! In this video, we're going to try and simplify our feature engineering strategy utilizing open source. In particular, we're going to use the feature engineering transformers from Scikit-Learn and from Feature-Engine. So in this video, we are going to take the notebook number 2, where we implemented all the transformations with pandas and NumPy, and replace those transformations utilizing the transformers from these open source libraries, and we're going to see the beauty that these transformers bring along when we use this instead of pandas. I won't discuss all the notebook in detail, just the bits of code that are new. We're going to make some additional imports respect to the second notebook of this section. We're going to import the binarizer for these hugely skewed variables. And from Feature-Engine imputation, we're going to import the add missing indicator to create these binary variables that indicate missing values. We're going to import the mean-median imputer to perform mean imputation, and the categorical imputer to impute with the string missing or with the frequent category. From Feature-Engine encoding, we're going to import the rare label encoder to remove rare labels, and the ordinal encoder to perform the encoding that we did in the second video. We're going to apply the log transformer and the Johnson transformer to our dataset. We're going to drop features with the drop features transformer, and we're going to use the sklearn wrapper transformer in combination with the binarizer just to binarize the variables that we want. The rest of the notebook you know already. We import the data, we separate the data into train and test, we apply the logarithm of the target. Here we determine the categorical variables. Here we find the variables with an A, with missing data. And now we create two lists, the list of variables that we're going to impute with the string missing, and the list of variables that we're going to impute with the frequent category. I can print them here. And now, to impute categorical variables with the string missing, we're going to invoke the categorical imputer from Feature-Engine, set up missing in the imputation method, and indicate which variables are the ones that we want to impute. With fit, this transformer doesn't really learn anything, but we can see that it stored in the attribute imputer_tick the values that it's going to use to impute each one of the variables. With the method transform, passing the training set and the test set, we obtain the datasets where no missing values are present in these variables. If we want to now impute with the frequent category, we need to invoke the categorical imputer, but set the imputation method to frequent and indicate which variables we want to impute with this method. When we fit the imputer to the training set, we can now see that this class has stored in the imputer dictionary the most frequent categories for each one of these variables. And now, if we store this class utilizing job_lib, we can then upload it in another notebook to, say, for example, make predictions on new data like our colleague wanted. There is no need for us to hard code these values anymore because they are learned and stored within the class. We can now apply the transform method over the train set and the test set and any other data set really to obtain the variables without the missing values. There were 3 numerical variables that contained missing data, which are the 3 ones that we see here. With the add missing indicator and passing the variables that we want to impute, we can add the indicator variables. With the fit method, this transformer doesn't specifically learn anything as we set it here. And with transform, it will add the missing indicators. So if we now examine the transform dataset, we can see that the variables were added. And to impute the variables with the mean, we use the mean-median imputer. We set up mean in the imputation method. We pass the variables that we want to transform. With fit, it will learn the mean for each one of these variables in the train set. And these values are stored in the imputer dictionary, which are these ones here. So now we don't need to hard code these values anymore. We just need to save this class and we can load it at a later stage. With transform, we remove the missing data in these 3 variables. We could capture the elapsed time utilizing the combine with feature reference class from Feature-Engine, but we're going to do it manually here, so this code is identical to the one that we used in Notebook 2. But to remove the year sold, we're now going to use the drop feature class, where we indicate which feature we want to remove, and then with fit transform in the train set, we remove the feature from the train set, and then with transform over the test set, we remove it from the test set. To apply the logarithmic transformation, we call the log transformer, and we indicate which variables we want to transform, and then we can apply fit transform over the train set and transform over the test set. To apply the EO-Johnson, we call the EO-Johnson transformer, we set up the variable that we want to transform, and then again fit transform over the train set and transform over the test set to perform the transformation. The EO-Johnson learns the best parameter for the transformation, which is stored in the lambda dic. And you can see it here. So again, we can save this class and recover it later so that we have the parameter stored. To binarize the variables, we need to wrap the binarizer from Scikit-Learn with the Scikit-Learn transformer wrapper so that we can apply the binarizer only to the skewed variables that we have here instead of to the entire dataset. The other beauty about the Scikit-Learn transformer wrapper from Feature-Engine is that it returns a pandas data frame. So with fit transform, we transform the train set, and then we transform the test set. The mappings that we use to encode some of these categorical variables, we need to do them manually. There is no class at the moment that allows us to do so. So this bit of code is identical. But to remove rare labels, we can use the rare label encoder from Feature-Engine, indicating the threshold that will determine that the category is rare. Here we need to set up the number of categories 1 and indicate which variables we want to encode. With rare encoder.fit, the encoder learns the most frequent categories for each one of the variables, which are stored in the encoder dictionary. So now we can see that we have them here for each one of the variables. So we can save this class to use it later. With transform, we encode the rare labels with the term rare. We can use then the ordinal encoder, indicating ordered in the encoding strategy, and the variables that we want to encode the strings by the numbers following the mean value of the target in each one of those categories. So this class here does exactly what we did manually with pandas in the second notebook of the section. With fit, and now we need to pass the train set and the target, it will create the mappings, and these mappings can be then found in the encoder dictionary, as we see here. So for the first variable, rare will be replaced by 0, rm by 1, rh by 2, and so on. And to finish, we will apply the min-max scalar from Scikit-Learn. So with this bit of code is identical, we call the scalar, we fit it to the train set, and then we transform the train and the test set. So what can we conclude from this? I think the code now is much simpler because most of the functionality that we coded manually in the previous notebook is now taken care of by the open source package. And now we have the option to save each one of these classes so that we can use them in a later stage. But we still need to save each one of the classes, so we're going to have multiple pickles. We need to load again each one of the classes when we want to score data. And then we would need to apply each transformation manually. This sounds like a lot of work, or at least it does to me, but we can simplify all of this if we put all of the transformations within a pipeline. So what happens with those transformations that we had to do manually, that we cannot find an open source class that will take care of this for us? Well, in this case, we need to create that class ourselves and maybe make it part of an in-house feature engineering package. So this is what we're going to do in the next couple of videos.